A cycle count is an inventory auditing procedure, which falls under inventory management, where a small subset of inventory, in a specific location, is counted on a specified day. Cycle counts contrast with traditional physical inventory in that a full physical inventory may stop operation at a facility while all items are counted at one time. Cycle counts are less disruptive to daily operations, provide an ongoing measure of inventory accuracy and procedure execution, and can be tailored to focus on items with higher value, higher movement volume, or that are critical to business processes. Cycle counting should only be performed in facilities with a high degree of inventory accuracy. The purpose of cycle counting is to verify the inventory accuracy, and even though it is not an adequate procedure to be used to correct inventory errors, it is an adequate way to identify the root causes of inventory errors. ABC analysis. Most cycle counting applications use ABC analysis, segregating items into various count frequencies. Determining selection method and count frequency. There are several methods of selecting which items to count and with what frequency, and each method has strengths and weaknesses. Pareto method. The Pareto method, derived from the Pareto principle, is to cycle count inventory by percentage of inventory value. Items with a higher determined value are counted more often, while items that have little movement are seldom counted. This sophisticated approach appeals to accountants by minimizing the variance in inventory value, and is efficient from a supply chain management perspective, concentrating effort on high volume of use items. The main shortcoming is that low-value items may be ignored and cause an entire assembly line to halt while a minor component is reordered. Cycle counting by usage only. Cycle counting by usage states that items more frequently accessed should be counted more often, irrespective of value. Every time an employee adds or removes an item, there is a risk of introducing inventory variance. Logical inventory zones can be set up to distinguish items depending on how frequently they are touched. This method may be biased against counting higher value inventory or require additional counting to satisfy accounting requirements. Hybrid. Most cycle counting frequencies are determined first by Pareto frequency analysis, and then changing the count frequency, or ABC code, as needed per item is based on per piece value, how critical the part may be, or other factors. This method requires manual arrangement and is not statistically pure since arbitrary adjustments can be made. Objective counting by surface area. Cycle counting that begins from one end of the store to the other, based on surface area. Combing over each rack or shelf, that is assigned per counter. This method requires planning, in which a map of the store is required and counting forms for the recording of stock information that will then need updating to the inventory management system. Automation. To conduct efficient and accurate cycle counts, many organizations use some form of software to implement an inventory control system, which is part of a warehouse management system. These systems may include mobile computers with integrated barcode scanners that allow the operator to automatically identify items, and enter inventory counts via keypad. The software then transmits data to a database on a host system which can generate inventory reports. Based on user-defined criteria, the software will select a number of items to count at specific locations for the specified period of time. Ideally, these selections are daily, but many companies choose to generate cycle count items weekly. Many companies perform many physical inventories and call it cycle counts. Instead of using random or system-generated part numbers at specific locations to count, they selectively choose specific locations and count everything in those locations. As part of their procedures, they rotate throughout the plant with the intention of counting every location a minimum of once each year. This is an effective alternative to true cycle counting, where a company may not have the sophistication to utilize cycle counting software. Dangers. Cycle counts can introduce inventory errors if the cycle count process is poorly executed. Multiple locations per item, work in process, and lag in paperwork processing can each contribute to errors. This problem can be mitigated with correct cycle count procedures that specify not only the part number to be counted but also the location it should be in. Cycle counting is only effective in companies with a well-defined inventory control procedure and a high degree of inventory accuracy. References: Essentials of Inventory Management, by Max Muller.